So we're going to start looking at fractions, and we're going to start with what we already know. So most likely you guys have you've been taught fractions as a part to whole ratio. Okay, and we could draw this part to whole ratio. So in this case here, we have a 5/6 fraction. So we should really think of this 5/6 as 5 parts to 6 parts whole. So this is my part, this is my whole. Okay, so if I'm going to draw this fraction, I can split it up into 6 parts whole. There's my 6 parts whole. It's a little bit more proportional here. Okay, so there's my 6 parts whole. And then the 5 parts that I want are going to be represented by shading in 5 of the 6 parts here. So I have 1, 2, 3, 4, 5. Okay, so that represents my 5 out of 6 parts whole. Okay, so this fraction bar represents 5 out of 6 parts whole. We could also think of a fraction as a number. Okay, and what I mean by number is a number on the number line. So we can say that that's 0 and that number is 1. And this position on the number line would then represent 5/6 as a number. As a decimal, okay, we can convert these to decimals, about 0.84. Okay, so if I were to show a decimal on the number line, okay, that would be about 0.84, about. Okay, we're not going to say exact, it's about 0.84, 0.84, 0.83, somewhere around there. Okay, as a fraction circle, we can do this. We can split this up into 6 equal parts. Okay, so we always know the nice thing about math is math is symmetrical. So whenever you have symmetry and be able to divide things up into nice equal parts, okay, we always try to do that. So that means that to draw a 5/6 fraction, well, I want 6 parts. So I know 6 can be divided into 2, and 2 is a factor. Okay, we know that 2 is a factor of 6. So we can start with a half fraction here. And then this is a little bit harder. So I need to make 6 parts. So we don't know thirds as well. So I know that 3 is a factor of 6. So I know I need to chop it up into thirds. So I'm going to do the best I can and chop it like that. Okay, so that's not too bad. There's my 6 parts whole. Okay, and then I need to shade in my parts here. My part is going to be, I'm going to have 1 part, 2 parts, 3 parts, 4 parts, 5 parts. Okay, so then that represents my 5 parts. And the whole circle represents 6 parts whole. Okay, so these are ways we can express fractions. We can express them as fraction bars, fraction circles, part-whole ratio. We can express them on a number line. A fraction can be a number on a number line. So we want to have some language here to be able to talk about fractions. Okay, and so when we talk about fractions, there is a numerator and a denominator. And we want to kind of make sure we understand what does the numerator represent and what does the denominator represent. Well, we know that the numerator, we've kind of done this before, the numerator, it represents the number of parts. Okay, so it represents the number of parts, and the denominator represents the number of whole parts. Okay, so our part to whole ratio. We could also express the numerator as, and this might be a little bit new to you, okay, but one way we can actually describe the numerator is how many pieces we have, and then the denominator represents how big the pieces are. Okay, so when we talk about a 1/6 fraction, it tells us how big the fraction piece is. A 1/6 fraction looks different in size than a 1/8 fraction or a 1/4 fraction. So the denominator can represent the size of the fraction, okay, size of fraction pieces. And the numerator would then represent the number of fraction pieces. Okay, so the number of pieces. So when we talk about 5, 6, the 6 represents how big each slice is. The 5 represents how many slices we have. The other thing we can say, and this is again might be a little bit new, but this is very important, so I want you to kind of highlight this one. In math, we have add, subtract, times, and divide. Well, in a fraction, we can represent the numerator as times. Okay, so we often say there's times on top, and on the bottom is divide. Okay, so we can actually think of this as math operations, and this is very useful because math is about operation. So we say times on top, divide on bottom. And I'm going to highlight this one because this one, times on top, divide on bottom, is a very, very useful way to describe fractions and how we can think of fractions as we do more math and more operations with fractions. So we could take a look at some animations here to kind of get a sense of what we're talking about when we talk about fractions.